Good morning. This is module 2, lesson 2. So let's get started. Read this along with me. And again, since you're going to be in class with your headphones on, do it quietly. Express metric mass measurements in terms of a smaller unit. Model and solve addition and subtraction word problems involving metric mass. So again, we're going to be using our metric measurements. You're going to be solving some word problems, just addition and subtraction, so they shouldn't be too painful for you. So I think you will probably do well with this. At this point, you should have already done your fluency. This is the application problem. And again, what I want you to do is to turn your Chromebook off, or I'm sorry, just pause the video so that you can do the problem and try the problem yourself. And then you can come back and see how I did it and see if it agrees, if you agree with what I did. So we're going to, read the problem with me. The distance from school to Zoe's house is 3 kilometers, 469 meters. Cammie's house is 4 kilometers, 301 meters farther away from Zoe's. How far is it from Cammie's house to school? Solve using an algorithm or a simplifying strategy. So I'll explain to you what those both are as we're doing this problem. But let's look at what we know. If you feel like, oh, I got this, you go ahead and pause the video, do it yourself, and then come back. But I'm going to go ahead and solve it now. So let's see what we know here. We've got the distance from school to Zoe's house is 3 kilometers, 469 meters. Cammie's house is 4 kilometers, 301 meters farther away from Zoe's. How far is it from Cammie's house to school? So if we were going to do a tape model for this, we would look at it and we'd say, well, we know that this total here is the distance to school. We don't know what that is yet, but we do know that this right here is the distance from Zoe's house. And Zoe's house is 3 kilometers, 469 meters. So what we don't know, we know that Cammie's house is even farther away from Zoe's, so it's another 4 kilometers, 301 meters. So we can solve this using the algorithm or a simplifying strategy. So the algorithm on this would be lining up our things that are alike. So we're going to do 3 kilometers, 469 meters, and we're going to do 4 kilometers, 301 meters. Remember that you cannot add unlike things. So we need to add kilometers to kilometers and meters to meters. So one way that we can do that, we can add up our meters first. 9 and 1 will give us 10, and then 1 and 6 is 7, and 4 and 3 is 7. So we have 770 meters, and we have 3 plus 4 is 7 kilometers. Now, if we wanted to put that all into meters, we could do that. Remember that kilometers, 1 kilometer is 1,000 meters. So if we had 3 kilometers, then we have 3,000 meters plus the 469. So we have 3,469 meters. Plus, same thing over here. 4 kilometers is the same thing as 4,000 meters. So we have 4,301 meters. We can keep it all in meters. Again, we're going to get the same answer. 7,770 meters, which is equivalent to 7 kilometers, 770 meters. All right, let's look at the next one. And here we have our different things that we have. And I said it backwards. I apologize. In the algorithm was when we put everything into the same thing. Simplifying was when we added the things that were already similar. So we know that Cammie's house was 7,770 meters from school. If you need to pause here, take a minute and look at it, go ahead and do that. All right, we're going to convert kilograms to grams and want to just clarify something here. So we have we have weight and we have mass. So weight and mass, although they're very similar, they are different. So weight is a measurement, it depends on gravity. So your weight on Earth would be different on the moon because there's less gravity, so you would weigh less on the moon. Mass, however, does not change. It stays the same and doesn't depend on gravity. We're going to use both words, weight and mass, in the math. There is a slight difference, but it's not important for you to understand that difference. I'm just letting you know that so that you can understand that as we're moving forward with here. So we're going to on here, and we're going to look at these different objects here. So if we were going to convert kilograms to grams, kilograms is similar to our meters. Kilo meaning 1,000. So 1 kilogram is 1,000 grams. This is not right. 1 kilogram is not equal to 1 gram. We definitely want to change that because that's not true. So as we're looking at these, though, we kind of get an idea. So each of these bottles of water is about 1 kilogram. A big dictionary is about 1 kilogram. A paper clip is about 1 gram. So you can see that you'd need about 1,000 paper clips to equal one of these, right? You'd need about 1,000 approximately. Remember our little symbol for that. And a dollar bill is 1 gram. Think of a dollar bill, it hardly weighs anything when you feel it in your hands. So that just gives you an idea of looking at it. So again, remember these bottles of water, these heavier things are kilograms, the big book, and then grams would be maybe paper clips, dollar bills. You could measure that way. All right, we're going to fill out this table, and I want you to try it on your own. So again, pause here. See if you can fill it out as you're converting, as you're going back and forth between kilograms on this side and grams on this side, remembering that 1 kilogram is 1,000 grams. So I want you to go ahead and try it on your own. So pause the video, then come back and see if you were right. All right, let's look at this. 2 kilograms, if we were going to convert it into grams, well, 2 times 1,000 would be 2,000. Let's go ahead and just fill in this side while we're at it. 4 kilograms would be 4,000. 7 kilograms would be 7,000. 8 kilograms, 8,000. And 10 kilograms, 10,000. Because each of these numbers we just multiply by 1. Each of the kilograms, we times it by 1,000 to go over to the other side. I don't know if you can tell what that says. It's pretty sloppy. I'll try and fix it a little bit. Alrighty, we'll try it times 1,000. Hopefully that looks a little bit neater. All right, so now let's go the other direction. So we have got us starting here. We've got 3,000 grams. So how many kilograms is that? Well, that's 3. We have to get rid of those 3 zeros on the end. So we're going from 5,000 grams to 5 kilograms, 6,000 grams to 6 kilograms, and 9,000 grams to 9 kilograms. And whoops, we'll see how that goes right there. Okay, suddenly my page got really small, but let's see. 0 minus 0 is 0. 10 minus 5 is 5. 9 minus 2 is 7. 9 minus 2 is 7. 7,750 grams is our answer here. I'm going to see if I can figure out what I did here, but I don't know what I did. Alrighty, so we're going to come back. That's one way we can do it. That's probably the easiest way with this particular problem. Although we can, now if we look at it and we want to just keep like units with like units, we could take our 10 kilograms. I'm going to do it just over here, 10 kilograms. And I can break that apart into 9 kilograms and 1,000 grams, because I know that 1,000 grams is equal to 1 kilogram. So these two together are equal to 10 kilograms. So I'm going to turn my 10 kilograms, I'm going to turn that into 9 kilograms, 1,000 grams. Now I can subtract my 2 kilograms and 250 grams. So we're going to do that same thing. We're going to turn this into 10 and then into 9, and then we'll turn this into 10 here. So 0 minus 0 is 0, 10 minus 5 is 5, 9 minus 2 is 7, and 9 minus 2 is 7 here. 7 kilograms, 750 grams, and these two are equivalent right there. So those are 2 ways that I could look at this problem. Again, pause if you need to so that you can look at it. Okay. Alrighty. We are going to look at this next one, problem 3. Subtract mixed units of mass using the algorithm or a simplifying strategy. The same thing that we did before. I'm looking at this one and I'm thinking, you know what? I think I can I'm going to do the same thing that we just did last time. So I'm going to turn 32 kilograms into 31 kilograms and 1,000 grams. So I'm going to turn that, I'll have 31 kilograms. I've got 1,000 grams here plus the 205 there, so 1,205 grams. And I'm going to subtract our 5 kilograms, 316 grams. So I'm going to do that. So I know I'm going to have to, I don't have enough ones, so I'm going to have to regroup here. But I don't have enough there, so I have to regroup here. And really regroup all the way over. 11 here, and this will become 10, and then I'm going to have to regroup, so it'll become 9. So I've got, and this will be 15. 15 minus 6 is 9. 9 minus 1 is 8. 11 minus 3 is 8. And 31, that's 889 grams. 31 minus 5 is 26 kilograms. Now I just want to make sure that I did do this part right. 6 and 9 is 15. 1 and 1 is 2. And 8 is 10. Carry 1 and 3 is 4, 12. So yes, I did do that right. So I just wanted to confirm that because sometimes it doesn't feel like we did something right. So we are going to, that's one way. The other way, remember, is to turn it all into grams. So 32 times 1,000 is 32,205. And grams. And then my 5 kilograms, I'm going to times by 1,000. That's 5,316 grams. And then I can subtract those as well. So again, we're going to have to, we don't have enough ones, so I'm going to look at the tens. I don't have enough tens, but I can go ahead and regroup using the hundreds. So I can turn that into 1, turn this into 10, and then I'm going to have to take from that and make this 15. So I've got 15, and then I can say I don't have enough in the hundreds, so I'm going to regroup here and take 1 there, but then I'm not going to have enough, so I'm going to have to regroup and turn it into 2 and 11 there. All right, 15 minus 6 is 9. 9 minus 1 is 8. 11 minus 3 is 8. 11 minus 5 is 6. And 2 minus 0 is 2. 26,889 grams. And again, those two are equivalent. So that was another way that we could do that. This next problem, solve a word problem involving mixed units of mass modeled with a tape diagram. So we are going to use a tape diagram to show what we're talking about. So let's look at this problem. A suitcase cannot weigh more than 23 kilograms for a flight. Robert packed his suitcase for his flight, and it weighed 18 kilograms, 705 grams. How many more grams can he add to his suitcase without going over the weight limit? So what we have here is a total. What's our total? Well, our total is the 23 kilograms that his suitcase can weigh. It can't weigh any more than that. Right now, his suitcase weighs 18 kilograms, 705 grams. So what we want to know is, well, how much more can he pack into that without going over? So what we need to do, remember when we have the total on the top, and then we have only, so we've got our total here of 23 kilograms, and we've only got a partial part down here, so that means that we need to subtract. So we're going to start with our 23 kilograms. I'm looking at this problem, I'm thinking, you know what, I want to just go ahead and put it all into grams. So 23 kilograms is 23,000 grams, right? And 18 kilograms, 18 times 1,000 is 18,000. And we have 705 grams here. So I need to subtract what I have to see what the amount that I've got left. So they are really having us do it across zeros, so really practicing that. So we're going to go clear over here, and we're going to turn that into a 2. We're going to turn that into a 10. And then we're going to have to borrow there. We're going to turn 9, 10, and we'll have to borrow and regroup there, and we'll end up with 10 here on the end. 10 minus 5 is 5. 9 minus 0, 9. 9 minus 7 is 2. You have to regroup here. And 12 minus 8 is 4, with 1 minus 1 being 0. Okay, remember that when you want to check something, you can do that by adding the bottom row and your answer. So 5 and 5 is 10, 1 there, that gives you 10. 1 here, 1 and 7 is 8, and 2 is 10. 1 and 8 is 9, and 4 is 13. 1 and 1 is 2. And that's what we started out with. So that confirms to me that 4,295 grams is our answer there. And if I were going to convert that into kilograms and grams, I would be 4 kilograms, 295 grams. And that's how much he can add to his suitcase. Robert can add in order to not go over. All right, there you are. You are going to do the problem set. So you're going to do those problems, and then you can go back with our guest teacher, and she can confirm those, and you can double check your answers with her. Have a good day.